Hello friends and my dear students, I welcome you all to my channel. I hope you are all doing well and your studies are also going on well. In this video is topic D of the series of videos on concepts to remember on the chapter properties of triangle, where I will discuss about the triangle inequality. So these series of videos titled concepts to remember are discuss the key points and the concepts and the formulas uh, on the chapter, and it is recommended that you see these series of videos only after you have completed the chapter and you have solved a lot of problems from the textbook and from any other reference book. So this series of videos is inspired from the things to remember section that you will find at the end of every chapter of most Indian standard Indian author textbooks. So this video is part of the playlist CBSE Mathematics for class 7 following the textbook of author R.S. Agarwal. If you are new to my channel or not yet subscribed, and if you are watching my videos regularly and my videos are beneficial to you, then please support me by subscribing to my channel, and also please do not forget to press the bell icon so that you will be notified by my future videos. So let's get started with this video. Okay, so I have all the key points listed down for the topic which is about triangle inequality. So this is chapter properties of triangles. If you have not watched the previous part A, part B and part C in this series of videos, that is concepts to remember, I highly suggest that you please watch them. It will help you to once you have completed studying a chapter. If you see this series of videos, it will give you a good evaluation of your understanding of the concepts, and you can use these videos as a checklist of all the key concepts that you need to remember and understand for solving most variety of problems. So let's start today's topic D, which is about triangle inequality. Now, the triangle inequality in a triangle says that, so in a triangle we always have the sum of the length of two sides is always greater than the length of the third side, and also the difference of the length of two sides, any two sides, is less than the length of the third side. So these two are the two important concepts of triangle inequality. So for the first one is that the sum of length of any two sides is greater than the third side, and the second one says that the difference of length of any two sides is less than the length of the third side. So in the figure in the triangle ABC, you know that the convention for the notation we use for denoting the length of the sides of a triangle is that we use small letter of the angle for the side opposite to the angle. So small a denotes the length of the side BC, which is opposite to angle A. Small b denotes the length of the side AC, which is opposite to angle B, and small c denote the length of the side AB, which is opposite to angle C. So in this triangle we will have A plus B greater than C, and also modulus of A minus B less than C. Modulus of A minus B, why we are using modulus? Because we do not know whether A is bigger, A is more than A is bigger than B, or A is smaller than B. Among the two side lengths A and B, which is smaller and which is bigger, we do not know. But we are only concerned with the difference, with the concerned with the difference of the length of the two sides. So if we have, say, if we have A equals 2 and B equals 4, then the difference is actually 4 minus 2. But if you do A minus 2, this is 2 minus 4, this is minus 2. That is the reason we are taking mod of A minus B, that will be mod of minus 2, that is 2. So we are interested only the difference, the absolute difference of the length of the two sides. So we are using the mod. So we have A plus B greater than C, and modulus of A minus B less than C. Similarly, we will have B plus C greater than A, and modulus of B minus C less than A, and C plus A greater than B, and modulus of C minus A less than B. So this is the very fundamental concepts of triangle inequality regarding the length of the three sides of a triangle. All other aspects, all other keys, concepts will be based on these two concepts. Okay. Point number 2 says that a triangle can be formed having side lengths x, y, z, where x, y, z are some positive numbers, if the following three conditions are satisfied. Meaning, if we are given three positive numbers, let's say x, y, and z, they are positive numbers, and if we are asked that whether a triangle can be formed whose lengths are these numbers, whose sides have the lengths having the numbers x, y, z, then we can say that yes, a triangle can be formed only if these three conditions are satisfied. The three conditions are, first one is that x plus y should be greater than z, and second one is y plus z should be greater than x, and third one is x plus z should be greater than y. This essentially means that you take any two numbers, you are given three positive numbers, you take any two numbers, if their sum is coming out to be greater than the third one, and this is true for any two numbers, then we can say that a triangle can be formed whose sides will have lengths x, y, and z. Okay. Point number 3 says that in a triangle, if A and B are the lengths of two sides, then the length C of third side will lie between modulus of A minus B and A plus B. So it means that so if you have a triangle, ABC, so we are having a triangle ABC. So let's and we are given only the length of two sides, that is A and B. Let's say we are given A and B, so this will be A and this will be B. We are given only A and B. A and B will be some positive numbers, and it will be said that these are the lengths of two sides of a triangle, and it will be asked what value the length of the third side can take, meaning what is the range of values the length of the third side can take will be, or what value the length of the third side will lie between. And so the answer is, the result is that the length of the third side, that is C, will lie between modulus of A minus B and A plus B. That is C, which is the length of the third side, will be greater than modulus of A minus B, that is the difference of the lengths of the two given sides, and C will be less than the sum of the lengths of the given two sides. Okay. Now point number 4 says that in a triangle, let's say in any triangle, let's say if we create a line segment from any vertex to a line segment, let's say we have a triangle ABC, any triangle ABC, and if we create a line segment from any vertex, let's say A, any vertex A, a line segment any vertex A by on the which will intersect the opposite side BC, or alternatively you can think it like this. Let's say we have a triangle ABC and we take any point on the side BC, and this point should lie on the side BC and will not coincide with the vertices B or C. So let's say I take a point D. It could be anywhere on the side BC. It should lie on the side BC and it should not coincide with the vertices B or C. Now if I join A and D, this line segment is what I am talking about. So this line segment, now in this scenario, what we will have is that we know that the triangle, the perimeter of the triangle, if I am representing the perimeter of the triangle ABC with capital P, so P is nothing but AB plus BC. In the notes I forgot to put the bar on the AB, BC and CA, but anyway, so we have this. The perimeter is the sum of the length of the sides of a triangle. So we have perimeter P equals to AB plus BC plus CA. Now, a result we will have is that based on using the concept of triangle inequality, we will have that the perimeter of the triangle P will be greater than 2 into AD. What is AD? AD is the line segment that I create that is formed by joining any vertex A and a point on the opposite side, and a point on the opposite side anywhere. That is, if I take a point D on the side BC, anywhere on the side BC, and if I connect A and D, I get the line segment AD. So I will have P greater than twice AD. Now this is true for, you can see in the figure, the first figure we are creating a line segment AD, that is by taking a point D on the side BC and connecting it with the opposite vertex, that is A. In figure 2, we are taking any point on the side AC, any point that is D can lie anywhere on the side AC, and we are connecting that point D with the opposite vertex, that is B. So BD is the line segment. Similarly, in figure 3, we are having CD as the line segment, where we take the point D anywhere on the side AB and we are connecting it with the opposite vertex C. So, so we will have, for all these line segments, it will be true that P, that is the perimeter of the triangle P, will be greater than twice these line segments. So we will have P, we will get three results, that is P greater than twice AD, P greater than twice BD, and P greater than twice CD, where AD is the line segment, connecting A and a point D anywhere on the side BC. Similarly, BD is a line segment connecting the vertex B and a point D anywhere on the side AC. By anywhere, I mean it should not coincide with the vertices. So this is this result we get, that the perimeter of the triangle is greater than twice a line segment that is formed by connecting a vertex and a point on the lying on the opposite side. I hope this is understood. Okay. Now point number 5 is that it is an extension of basically extension of point 4 utilizing the results from point 4. Point 5 is nothing but, you see in point number 4 we are getting three results. In point number 4 we get results that P is greater than twice AD, P is greater than twice BD, and P is greater than twice CD. So we have these three results. Now if I add up these three results, adding 1, 2 and 3, we get, by adding means we add all the left hand side terms and we add on the right hand terms, and the inequality remains same. So we have P plus P plus P is greater than, we will have twice AD plus BD plus CD. So this implies 3P, P is the perimeter of the triangle ABC, 3P is greater than twice AD plus BD plus CD. So what these results says is that in any triangle, if you create these line segments, that is the three, you create the three line segments, that is that is a line, three line segments means from any vertex A, from a vertex the line segment formed by connecting a vertex and a point anywhere on the opposite side, that is a line segment. Similarly, for all the three vertices you will have three line segment. So thrice the perimeter of the triangle will be greater than twice the sum of those three line segments. That is in the figure on the left hand side, you can see the line segments are AD, FC and FE. Sorry, AD, FC and BE. So we will have thrice P, where P is the perimeter of the triangle, that is AB plus BC plus AC. So thrice P will be greater than twice the sum of the line segments that is formed. Okay, let's see point number 6. Point number 6 is that if you take, we have a triangle ABC, any triangle ABC, and if you take a point O inside the triangle A or outside the triangle A, meaning by saying that the point O lies inside the triangle A or outside the triangle A, it means that the point O should not lie on the triangle A. That is, if ABC is a triangle, let's say ABC is a triangle, the point O should not lie on any side. The point O should not lie on the side AC or AB or BC. Anywhere else, it is either outside the triangle or it is inside the triangle. This is an inside the triangle point, and this point is outside the triangle. So anywhere the point O can lie anywhere. So I have drawn two figures. The first one, the point is lying inside the triangle A, and in the second figure, the point O is lying outside the triangle ABC. Now, so where you have this point O, we create the three line segments, that is joining the point O with the three vertices A, B and C. So we have three line segments OA. So let's say the point is outside. Let's say the point is outside the triangle ABC. So the three line segments that we are forming is connecting the point O with the three vertices. So this is the line segment OA. This is another line segment OB, and this is another line segment, that is OC. So these three line segments, we will have a relation between these three line segments and the perimeter of the triangle, and the relation is P is less than twice the sum of the lengths of these segments. That is P, we know P is AB plus BC plus CA. If you can also write it as AB is the length of the side AB is denoted by with small c, because if the side AB is opposite to the angle C. Similarly, the length of the side BC is denoted by A, as the side BC is opposite to the angle A. So A plus B. So basically this is small a plus small b plus C. So the relation we are having is that P is less than twice the sum of the length of the three line segments that is formed from the point O joining the three vertices, and this point O can lie inside the triangle or outside the triangle. So this is the relation we get. Okay, so this is point number 6. So this is regarding a point O lying inside the triangle, in a triangle ABC, lying inside the triangle ABC or outside the triangle ABC, and we have this relation between the perimeter of the triangle and the length of the line segments that is formed by connecting the point O with the vertices of the triangle ABC. Now the same relation we have for a quadrilateral. The point number 7, we have a quadrilateral PQRS, and no, point number 7 is something else. The point number 8 is regarding the point O, regarding quadrilateral. Okay, let's first discuss what is point number 7. The point number 7 is that if you have a quadrilateral PQRS, so we know that that its diagonals will be PR and QS. So the relation we will have, all these relations are all based on the triangle inequality, that is the sum of any two, the sum of length of any two sides of a triangle is greater than the length of the third side. So in point number 7 is that if we are having a quadrilateral, any quadrilateral PQRS, so we will have the diagonals PR and QS, and the result we get is that the perimeter is greater than twice any diagonal. Since we are having two diagonals PR and QS, we will have two results, that is P is greater than 2PR, P is also greater than 2QS, and if you combine these two results 1 and 2, you can have P is greater than PQ, PR plus QS. That is, the perimeter of the quadrilateral will be greater than the sum of the diagonals. The sum of the diagonals means the sum of the length of the diagonals. So you can see where obviously the perimeter of the quadrilateral is the sum of the length of its sides, that is PQ plus QR plus RS plus SP. Okay. Point number 8 is regarding a quadrilateral PQRS, any quadrilateral PQRS, and a point taken inside the quadrilateral or outside the quadrilateral. Now over here, since it is a quadrilateral, we have 4 vertices, so we will have 4 line segments formed by joining the point O with all the 4 vertices or corners of the quadrilateral PQRS. So in this over here, the relation we get is that perimeter, that is P of the quadrilateral, is less than twice the sum of the line segments formed. So the line segments formed are OP, OQ, OR and OS. So we will have P less than twice OP plus OQ plus OR plus OS. But obviously the perimeter P is equal to PQ plus the perimeter P is the sum of the length of the sides, 4 sides. So this relation we have is that irrespective the point O can be inside the quadrilateral or it can be outside the quadrilateral, and it is creating 4 line segments, that is the line segments by connecting the point O with the 4 corners of the quadrilateral, and the result is that the perimeter will be less than twice the sum of the 4 line segments formed with the point O and the 4 corners of the quadrilateral. Okay, this is point number 8. Okay, that is all regarding the key aspects or points based on the triangle inequality. The basic core 2 concepts of triangle inequality is that sum of the length of any 2 sides in a triangle is greater than the length of the third side, and the second one is that the difference of the length of any 2 sides of a triangle is less than the length of the third side. Okay, so that is all for all the concepts in topic D on the triangle inequality. I have prepared a samples problem. The link of the PDF of the sample problems I will attach. I will provide in the description below. You can check that out. And if you need the solution video for all the sample problems, please do let me know in the comment section. I will prepare them and upload them very soon. So the next topic E, one topic is left, that is Pythagoras theorem, and that will bring an end to all the concepts to remember on the chapter properties of triangles. I hope this video was beneficial. If it is, then please like it and share it with your friends, and please once again support me by subscribing to my channel, and also do not forget to press the bell icon so that you will be notified by my future videos. So that is all for today's video. Until the next video, take care and bye.